Thank you very much. Just give me a second to arrange stuff so that I can see at least a few of you while I explain what I have in mind. Okay, great. So a big thank you, first of all, to my co-organizers for organizing this event with me. It's been a great pleasure. You guys are wonderful. And a big thank you also to all of you who are coming here to listen to the talk and see what this is about. So what I'm going to present is an attack which Stefan Hartmann and I recently launched on what is arguably one of the more fundamental assumptions in the scientific study of consciousness, and that is the closure of the physical. So in this talk, I'm not going to present the formal details on which our result actually relies. So I've played around, but 15 minutes is just too short to get anything meaningful across. So what you'll get here is the intuition and the argument. But please bear in mind that all of this can be made a lot more precise. And if you're interested, the paper preprint is already out. Okay. I will also try to pump your intuitions, and I'll do so by making use of an assumption, which is not at all required for the result, but which makes it very vivid. And that assumption is generally called T-shirt physicalism. So the idea is, or the assumption says, that all physical events are fixed by the fundamental laws of physics and the initial conditions right after the Big Bang. And it's called T-shirt physicalism because the laws are supposed to fit on a T-shirt, but that doesn't matter for us. So the idea is that we have some initial conditions right here, and then the laws are what they are, and then just everything else is determined. And just a note, I'm going to be using the term physical events to refer to the kind of event that is subject to natural science. So for example, electrical currents, which are instantiated at some time, air molecule movements, distribution of magnetization vectors, but also the movement of my hand, yeah, or also like the basically the sound waves that propagate now as I speak. All of these things. And of course, T-shirt physicalism is a very comprehensive assumption because somewhere in this, very rich account of things is our galaxy, and there's our solar system, our Earth, and maybe there's also your experiment on consciousness. So let's have a look at that real quick. So here's a typical experiment, in this case from the Dehaene group. So what they would do is they would show you a stimulus, in this case a number somewhere in your visual field. Then there would be a delay, and then they would mask that stimulus. And subsequent to that presentation, the subject would then be asked to do two tasks, an objective task, basically to compare the number they saw to 5, was it equal to 5 or not, and a subjective task, basically to rate how well they saw the original stimulus. And the result of the experiment, on the one hand, are the keystrokes, or to be more precise, the data that is generated by the keystrokes when the subject answer these results. On the other hand, while they present the stimulus, they would collect EEG. They would then run source analysis to get this kind of information, which tells you basically where the EEG signal that they recorded would likely be originating. So the point is, we have these two results. On the one hand, EEG signals, on the other hand, keystrokes and electrical signals. Well, the point is, all of these are physical events. Yeah. So in particular, so they're the kind of event which is studied by natural science. And the same holds true also for other experiments, like for, as I just indicated, if you have verbal report, well, the sound waves are also physical events. Okay, so now that we have physical events appearing in experiments on consciousness, we better check what kind of commitment any theory of consciousness has with respect to these or other physical events. And the commitment is generally all the same with all theories that we have in at least the neuroscientific study of consciousness. And that is given or determined by the closure of the physical. Now, up to slide number 7, I'm going to work with this definition. So a theory of consciousness obeys the closure of the physical, no causal here, if and only if it does not posit any changes to the physical events explained, predicted, or otherwise determined by natural science. So that means a theory obeys the closure of the physical if and only if it just buys into whatever it is that natural sciences say about physical events. So for example, in the case that we just had, well, neuroscience accounts for what your brain does. So the theory would just buy into whatever it is that neuroscience says about your brain. No replacements of the physical events explained or predicted or determined by natural science, no modifications, no additions. So just to make it very clear what that means, so if we combine this assumption of the closure of the physical with the T-shirt physicalism, well, we get that a theory of consciousness obeys the closure of the physical if and only if it just buys into the very picture provided by the initial conditions and the fundamental laws. Doesn't matter whether we know the picture in detail or not. Doesn't matter whether we know the sort of events that are actually determined by natural science. All that matters is that it buys into that, whatever it is. Okay, so you can see that the problem is emerging already. Why so? Well, because we have several different theories that obey the closure of the physical. Basically, all of the neuroscientific theories and also others subscribe to this assumption. But then, as we have just seen, at the very least in this case where we assume T-shirt physicalism, well, they all buy into the very same picture right here. But as we have also just seen, well, that includes not only, like general physical events that happen right now, but also the kind of physical events that constitute the measurement results in your experiments. And so what that means is, so they are part of this story here told by determined by the physical laws. And what that means is that we have different theories that buy into the very same story. And of course, that's problematic. And we're just about to find out why exactly. So it's always good to know when your assumptions are crappy. And usually that's a sufficient condition. So that's not yet the crappy part. So I'm introducing the following terminology. So we'll just call two theories of consciousness empirically indistinguishable if there's no experiment whatsoever which allows us to distinguish between those theories. So put differently, if whatever they say or imply on different experiments, either directly or implicitly, depending on the assumptions they buy into, if that's exactly the same in the two cases, we call them empirically indistinguishable. And this is really just to say that this here illustrates the kind of measurements we have in neuroscience right now, or actually 2014. So you see there's a huge time range and a huge size range which we can measure. And that is just to illustrate there's a lot of detailed information we can measure. And the same holds true for subjective or objective measures of consciousness. So that's just to say this is a really weak requirement. We're just asking if there's no way to even distinguish theory, well, that's not so good. And it's justified in calling them empirically indistinguishable. In physics, that actually only happens if you have two mathematical formulations of one and the same theory, like, for example, matrix mechanics and wave mechanics in the case of quantum theory. So it's something that you would never, ever otherwise have. And now we're going to top that off. We're going to say, well, if we have an assumption and the implicit premises, which is basically satisfied by several vastly different theories, as is the case for the closure of the physical, and if that assumption implies not only that there's some theories that are empirically indistinguishable, but it implies that all of the theories that obey this assumption are empirically indistinguishable, well, I and Stefan think that's a sufficient reason to call that assumption unscientific. If you don't like that word, you can also call it crappy, but I think unscientific is more appropriate because in this case, the assumption implies that no experiment which tries to distinguish between those very theories can even be conducted, or at least whatever you do, it is actually meaningless. So that's certainly an assumption we want to avoid. And just to emphasize this, it's a very weak condition, and it's independent of the science demarcation problem. And the second thing, it's totally independent of your preferred choice of theory testing. If you like falsification, like Eric and me a while ago, well, that's fine. If you like corroboration, that's fine. If you're a Bayesianist, that's fine. It's really independent of these kind of things. Okay, so that's it already. Let's put the pieces together. Okay, we saw on the one slide that measurement results are physical events. In the paper, we actually establish on another route that they're determined by physical events. Both are fine. Well, then the closure of the physical was defined as a theory buying into whatever it is that natural sciences say. So if we have two theories which obey the closure of the physical, T and T prime, well, that means that they're committed to the very same physical events, namely those explained, predicted, or otherwise determined by natural science, by definition of how we have defined this notion. But if we bring in the first line, that means that two theories of consciousness which obey the closure of the physical, they're committed to the very same measurement results, simply because measurement results are physical events. And that's what I just told you on this picture a few slides ago. So the measurements are part of that story and they buy into the same story. So you see, how can the measurements differ? They cannot. So basically, this implies that there's no single experiment whose results differ according T and T prime, simply because they buy into the very same physical events, and simply because the physical events determine the measurement results. Okay, now it's just a matter of applying the definitions on the last slide. So that was actually a sufficient condition for calling theories empirically indistinguishable. And since T and T prime were arbitrary here in this little scheme, so I didn't fix them, it holds actually for any T and T prime which obey the closure of the physical. And that implies, therefore, that the closure of the physical satisfies our very weak sufficient condition of being unscientific. So I'm writing this as a theorem, and let me just move that to the next slide. So here you see the theorem again. And I'm writing that as a theorem because in the paper, we actually prove this. The mathematics are very simple, and that was part of the sort of the difficulty in getting the math so simple that it's, at least we hope, like ultimately convincing. So if you look into the paper, you're going to get a proof of this based on a precise definition of the terms I've used. You're going to get a proof which holds independently of this reductionist assumption of T-shirt physicalism, which I've used here. And you're going to get sort of something which is built on a necessary condition for something to be a result of a measurement. So you don't have to go through the individual measurements and see if you agree that there is what they call result is actually a physical event. That's something that this necessary condition does for you for all measurements and all experiments at once. Okay, and now in the last 3 minutes, if my clock is correct, to the elephant in the room. Yeah. So how does this all relate to the causal closure of the physical? Well, so the causal closure of the physical, there are slightly varying definitions, but the general scheme of things is this. The causal closure of the physical is defined as the assumption that every physical effect has a sufficient physical cause. So that means every event which is an effect has a sufficient physical cause. So how does this relate to what we have defined? Well, what we have defined is an epistemic notion. It just depends on whatever you write into your theory of consciousness, not an ontological statement like this one. It doesn't speak about how things really are. It just speaks about how you describe things. So what we need to do is we need to study the epistemic repercussion of this assumption and see whether it agrees. Unfortunately, that's not easy to do because this assumption is extremely imprecise. It leaves completely open which notion of causality you're supposed to take. It leaves completely open which ontological commitment to causality is presupposed. So in physics slang, whether causality is something fundamental or not. And even though the last point is much more discussed in the debate, it leaves open what the causal relata of this causal relation are. So what precisely are like the physical, what does physical mean even? So that is just to say, things are too imprecise to make a connection. And it's at least I would figure not a good strategy to just plug in some choices here and see where you get. There's a much easier way, in fact, and that's just to take a look at what people say, because they actually tell us what they take the epistemic repercussions to be. And so let's work with this. So this is something I found in Jack Wong Kim and Frank Jackson's work. It's of course paraphrased in my own word, but they say explicitly that the causal closure of the physical, defined as up here, implies that every physical event which is explained at all is explainable by natural science. Okay, that's great. So let's apply that to a theory of consciousness. Well, if every physical event which is explained at all is explainable by natural science, then surely every physical event which a theory of consciousness explains can be explained by natural science. But that means that T must not replace, alter, or add to the natural science account of physical events. It implies that, sorry. So, because if it would replace some of the events that natural science predicts, posits, or determines, well, it would break the explanatory link. If it would alter some of the events that natural science explains, it would also break the explanatory link. And if you would just add new physical events, it would put a set of events that are explained by natural science. Well, then it would also bring in something for which there is no explanation. So that's really more or less a reparaphrasation in the next line. So if it doesn't replace, alter, add to the natural science account of physical events, well, that means or implies that T must not posit any changes to it. So it can change whatever natural science at the very least explains about physical events. And that is equivalent, at least if you make it a little bit more precise, see further paper, to the closure of the physical. Yeah, so that's it. So maybe just to wrap things up, on this slide, I want to add that on the paper, we actually spell out mathematically what it means for a theory to obey the closure of the physical, and then we show that this statement implies precisely what we spelled out mathematically. So what you see here is really the causal closure of the physical implies the closure of the physical. Okay, so I'm done. The conclusion, you can read through them if you like. Basically, just it's a major assumption, and we've just seen that it's somehow fishy. Apologize for the language. Yeah, thanks for the attention.